name is Vivian Plasencia, and I'm a software engineer in PSC at the Ethereum Foundation. And today we're going to talk about privacy with Semaphore. This is the structure of the presentation. We are going to start with what is Semaphore. Then we are going to talk about some use cases. We are going to talk about the Semaphore tech stack, the architecture of CK applications and protocols, and also some the main Semaphore core concepts. And we are going to talk about the circuit diagram of Semaphore, how to use it and how to use Semaphore, and also the architecture of an application using Semaphore. Let's start with what is Semaphore. Semaphore is a zero-knowledge protocol that allows users to prove their membership in a group and send messages such as votes or feedback without revealing their identity. This means that messages are not attached to identities. This means that they have no link. And Semaphore also provides a simple mechanism to prevent double signaling. And it works off-chain and on EVM compatible chains. So you can use Semaphore off-chain on a Web2 application. It's also compatible with any EVM compatible chain. These are some use cases. Semaphore can be used for anonymous feedback, anonymous voting, or anything related to anything anonymously that you want to do inside a group. And some example of projects, there is a link to all the projects here, but some examples are the SUPAS project that we are going to use at DevConnect, and we used it before at DevCon, and it's a ticketing platform. And also the Word project is for anonymous proof of personhood, and also the Pairwise project, which is for anonymous voting. This is the Semaphore tech stack. There are some circuits with Circom, and the smart contracts are with Solidity, and also the front end with JavaScript, TypeScript. And the proving system that we are currently using is cross-system, and you can get that by with Circom and Snare.js. You will be able to have it. This is the flow of a CK application. All the CK application will have a similar flow. The user will interact with the front end, the user interface, the application, and will generate the proof there. The CK proofs should always be generated in the user's device, in the browser or mobile. And then the user interface is gonna talk to the smart contracts or the Web2 backend to verify these proofs. So that should be the right way to do it. The proof should always be generated in the front end, in the user interface, and verified in the backend or the smart contracts. Here we are going to talk about the architecture of CK applications using Circom and Snare.js. So first, we have the circuits. We have the circuits here, and with the circuits and using the Circom compiler, we can get the WASM file, which we will use it after in the front end. And then using Snare.js, you can install it globally in your computer, and using Snare.js, you can get the CK file, and then also generate the Solidity verifier. Then we are going to use the WASM file and the CK file to generate the proof using Snare.js in the front end. This should always be in the front end to keep privacy and anonymity. And then you will use the Solidity verifier to verify the proof in the smart contracts. So this is the architecture of any CK application using Circom, Snare.js, any CK protocol. So it's the same for all of them. All of them should have this under the hood, even if you see it or not. So the architecture will be the same. And actually similar to Noir. You will study that later, but it's very similar to Noir. It won't have the WASM CK file, but it will have a JSON file to represent the circuit, and then it is very similar. These are the Semaphore core concepts. In Semaphore, we have identity, group, and proof. The identities are in the DSA. I will talk a bit about it now. And then groups are created with LinIMT, which is the binary Merkle tree and incremental Merkle tree we are using. We created for Semaphore version 4. And the proof, which is created with Circoms and RJS and also gross system as proving system. And that's the CK part. So the CK part is in this package, in this part of the concept in the protocol. You can read more about this topic and more in depth in this link. This is the Semaphore version 4 specification. The Semaphore version 4 identity consists of an EDDSA public-private key pair and a commitment. So you can create and verify signatures out of the box. So you will have the private key and then a public key and a commitment. So you will use your public for people. What you will use more is your commitment because that's the public value. And that's what we will add to the group. So the public key is for you to know that exists and is still public, but your identity publicly will always be your commitment. And you can find more about it in the documentation, the Semaphore documentation, the identities section. The identities can be created this way in the front end. For example, you can, it should be in the front end because the user will have their private key and all their private data. So it should be in the browser or their mobile. And you import the Semaphore protocol identity package and you generate the identity this way. This way is to create the random identity. So there is no value in the constructor. And then if you want to create the deterministic identity to generate the same every time with from a secret value, you can create it this way. And then to export it, you can export it using the export function. And then you can also import it this way to use the same identity after to save it somewhere and then import it from there. So use it again. The groups. So the groups are like anonymity sets. They are binary Merkle trees in which the leaves are the identity commitments. And groups are to represent a group of people, for example, but there are some other applications with groups can be credentials or something different, but most of the time groups are people with their identity commitments. And groups can be created off-chain with the JavaScript library or on-chain with the Semaphore contracts. So with the JavaScript library is this way, this side, and you import the package and then you create the group this way. You add a commitment to the group and that will add a leaf to the tree because what is happening under the hood in the groups is a binary Merkle tree, the LinIMT specifically, which is an optimized incremental Merkle tree. And then you can remove a member this way. You can add the index and then remove that member at that specific index and also update the member. And you add the index and also the member, the identity commitment you want to update, the new one. And in the contracts, you import the Semaphore contracts library, and then you can just use the interface and import it in the constructor and then create a group this way, call it this way, and you can call all the other functions the same way. The LinIMT is the data structure for group operations that Semaphore version 4, which is the latest Semaphore version, is using. And this LinIMT is an improvement over the incremental Merkle tree that we were using in version 3. So we were using a normal incremental Merkle tree, which is a Merkle tree that you can add, remove elements in an efficient way. So we created the LinIMT for this latest version to have a better performance. And the key improvements of the LINA-MT over the incremental Merkle tree are that there are no more zero hashes. So if you have studied a bit about the incremental Merkle tree, and you will know that, and also the Merkle tree, you will know that there are some zero hashes. So when you need to create a parent of a leaf, and then you don't have a sibling to hash it with, so that you can create the parent, that you will create a zero hash to represent that there is nothing there, and then you will create the parent this way. So in Lina empty, that's no longer needed, since right now what we do is that we send the same leaf to the parents, and then that's what we do, so that we don't have more space, unnecessary space. And it's actually more efficient too, because you don't need to calculate that hash. And also it supports dynamic depths now, because before you will create the incremental Merkle tree with specific tree depths, and you will say, okay, my tree depth is 10. And now with Lina MT, you don't need to do that. Your tree will grow over the time while you add more members to the tree. So you can find the paper here in the CKKit or organization like ORG, like the website of CKKit. You can find the paper, the Lina MT paper there. This is a representation of incremental Merkle tree and also the Lin IMT. And as you can see here, the incremental Merkle tree, the number of leaves will always be a power of 2 elements, because you need to hash all of them to create the parent hash. And so you will always have a power of 2 elements, even if you have 0 hashes. And with Lina empty, this is different. You don't need to have a power of 2 elements with 0 hashes. You just do what I was talking about before. You just, for example, in this case, you just send the same value to the parent, and then you hash when it's necessary, when you have a sibling to hash. And that's more optimized in terms of performance and space too. Those were the groups, and there's also the CK proof part, because after creating your identity and joining a group, users can anonymously prove that they are members of that group and also send messages. And these messages can be votes, feedback, or any other text message. And to generate a valid proof, we also need the scope. And this scope can be used to prevent double signaling, which means that your message or your CK proof won't be verified successfully twice. That's what double signaling means. So with the same scope, you will prevent double signaling, and with different scope, you will have multiple signaling. So you will be able, if you send different scope, you will be able, a scope is like a number or an identifier for the proof. If you send a different one, then you will be able to have multiple signaling. And I'm gonna, when I explain the circuit part, you will see why. So first with the concept, and then you will see why this happens and how. You can learn more about the proofs in the documentation too, the proofs section. The CK proof can be generated off-chain with the JavaScript library, and then they can be verified both on-chain and off-chain. So in JavaScript, you can just import the package, and then this is the scope. Let's say in this case, we are using the root, so that that's the identifier of the proof. And then this is the message, and this is the way to generate the proof. You just call the generate proof function, and you add the parameters, and then you can verify the proof this way, just passing the proof. And then this will return true or false, whether it was successfully verified or not. And also in the contrast, you can validate the proof too. In this case, in the contrast, there are two functions, one to verify the proof, which will just verify the proof, say if it's true or false. But then there is also a validate proof function that will say the nullifier, which is another concept we will talk about during the circuit explanation. And it will do something else to prevent double signaling. So this why it's called very validate proof in the contracts, and then you can just call it this way, just validate proof. You send the group ID, the ID of the group, and then the proof. Let's talk about the semaphore circumcircuit, the diagram. This is the circumcircuit of semaphore. We're gonna go through all the sections. So the first part we see here is we see like the Merkle proof length, Merkle proof siblings, and the index. These are private values, and then this is the circuit to generate the Merkle proof. This can be seen as the proof of membership. So using the Merkle proof of membership, you can generate the root calculating the index. You can think of this as when you have the list of indices, we will do that in the circuit. So you can see that you can think of it like there is a list of indices, but in real life it's just one value. And then using these indices and the siblings, you can calculate, and the length, you can calculate the Merkle fruit, and then you will have it here. That's a public value because we want to check it after in the contrast or in the backend. And also there is this secret private value. And the secret is not exactly the private key. This is part of the identity. This is not exactly the private key. This is generated from the private key, but it's still a secret value. So it should be secret. That's why it's private. And then with this secret value, with baby Jub, we generate the public key. And then this public key, this is a point, two values. And then we hash them and we generate the identity commitment. And then this identity commitment, which is your public identifier, we will use it to calculate the Merkle fruit with the siblings and the indices. And there is also this public value, the scope. And the scope is the one that we will use to prevent double signaling. And the secret with the scope, we will hash it using Poseidon. Poseidon is used in the circuits. In most of the CK circuits you will see, they will use Poseidon because it's more efficient in circuits. So that's why, because it's a CK-friendly hash function. And then we hash these two values, and then we get the nullifier. And the nullifier is what is used in the contracts, for example, or in the backend if you have a Web2 application. It's what is used to prevent the double signaling. So if you send a proof with the same nullifier, that's why it's public, because you need to check it. If you send a proof with the same nullifier, it means that you already, if your nullifier is safe in the contract, that there was a successful verified proof with that, and you send a proof with the same nullifier, you should be able, if you're not, you should be able to verify it, because it's like you already sent a proof and it was verified. So you shouldn't try to verify it again. And then there is also this constraint here, which is the message. It's a dummy with the message, a dummy square. This is actually needed in Circom, but in NOR you wouldn't need that. So in NOR, actually, the architecture is exactly the same. There is a Semaphore NOR implementation and it's exactly the same, except this dummy square, because that's not needed. And why with that we need it? Because when you send, message is actually a public input signal. When you have an input signal, if you don't use it in the circuit, then the Circom compiler will optimize your circuit, and then it won't create a constraint with that. Then if we don't create this dummy square, people will be able to send different messages with the same proof. So, and then you won't be able to verify that this message is attached to that proof. So that's why this is needed in Circom. And in NOR, this is not needed because NOR will always will always create a constraint for the input. So that's why it's not needed. But in Circom, is always needed. If you have an input and you don't use it, you should create this dummy square. So this is the architecture of the circuit. This is Semaphore protocol in circuits, just that. So to start using Semaphore, you have three main ways. You can use the CLI, the boilerplate, or you can also install the packages manually. So when you use these methods, this means that you won't need to do anything with CK related to circuits or anything related to the artifacts. So you won't need to do anything because you will have everything under the hood. So you will only do what I showed before, like importing the packages and just using the functions. So everything is abstracted. When you use the CLI, you can create a new project this way. You can just use npx and call this, and in this case, it will create a full app with ethers, and then you can also install the CLI globally and create the project this way. And there are different templates. There is one with for just contrast with hard hat, and one for full app with ethers and full app with the subgraph protocol. And then there is one for contrast foundry, and there will be more in the future. And the CLI can also be used to fetch group data if you want to know about a specific group. You want to know some information, you can just, for example, use Semaphore get group in Sepolia. Let's see which groups exist there and things like that. There are a lot of different things you can query there using the CLI. Here is the way you can access the CLI, more documentation here. There is also the boilerplate, which you can fork or use it as template here. There is a button here to use it as template and create one from scratch. And you can check the live app here. This is the live demo. And you can check it out to see the flow of an application. You can also install the packages manually, and you can find all the packages here in the main repo, and you just install them and import the packages and use the package directly without boilerplate or template. I'm gonna explain now the architecture of a Semaphore application. So this is how you should build a Semaphore application, if it's on-chain or off-chain. I'm gonna explain on-chain, which is with contrast, solidity, and also I'm gonna explain off-chain, which is with Web2 in a backend, like Node.js, for example. So this is the architecture of a decentralized application using Semaphore. You will have your contracts, and then you will import the contracts package of Semaphore with the contracts. And this contract will emit blocks that you will read to do some things in the front end. So this is the contracts part. And then you also have the off-chain part, because that's the on-chain part. Then you have the off-chain part. And in the off-chain part, you have the front end and also something to send transactions, which can be a relayer or a backend that you create for the transactions. And why we need that? Because we don't want to link Ethereum addresses to the identities and the proofs. So, I mean, we don't want to link the Ethereum addresses with the transactions to the CK proofs that the user created, because we will know that this Ethereum address created this proof. So this CK proof. So we want to use a relayer or also a backend. That's also fine. You can create your own backend. Then in the front end, you will use the identity package, because you should always create your identity in your device. And then you will use the group package, because every time you generate a proof, a CK proof, you need to recreate the group in the front end so that you can calculate your Merkle proof and create the CK proof. Because as we saw in the circuit, we need the Merkle proof so that we can create the root. So then we need the group package to create the group and regenerate the group. And how we are gonna get the identity commitments using the logs. We fetch that. There is a package to make it easier, like a package with ethers and another with a subgraph. So you will just fetch that data and regenerate the group in the front end, and then use that to create with the proof package to create the CK proof. And then this data package is what we use to interact with the contracts to fetch data from the contracts. And that's the architecture of a decentralized application. So no circuit here, no, you don't need to take care of that CK artifacts or CK part. And similarly, the off-chain architecture is like you will have the same things in the front end, but instead of fetching data from the contracts, you will just ask the backend because you will have all the data in the backend, a Web2 server, and then in the backend you will do all the group operations to add members and do everything. And then this proof package in the backend is to verify the proof, because you can verify the proof on-chain or off-chain. And then in this case, this proof package is to generate the proof, and here is to verify it. And there is the database to save the data. So in contrast, we save it the contracts, but then in Web2, we need a database to save the data that will interact with the backend. So this will be the way for a Web2 application. You can learn more about Semaphore in the main GitHub repository, like in the organization in general, and also in the documentation. And you can also join the Telegram chat and ask any question. And here is the website. You can check it out and see projects and past presentations and things like that, more information. So thank you.
Thank you very much. Do we have any questions?
I think that was super clear. Thank you very much. I might have one question on the group, because I thought at the beginning the group was like a group of people, but it's actually like one person have one group, or multiple people can share the same group.
A group is the group will have multiple people. Yeah, and actually, you shouldn't have a group of one person because there won't be anonymity there. It's just one person. Actually, the group should have as many people as possible so that the anonymity set is bigger and it's more difficult to identify things.
And people are assigned randomly to a group, or you can choose which group you can upload.
For example, yeah, you can create the group as you prefer. It's very open for people to adapt it to their application. For example, one easy example is that in this meeting, we have many people, and then we can create a group of people that are in this meeting, and then you will all send me your identity commitment from the Semaphore identity, and then I will add all this identity commitment to a group. And this way we can, for example, send feedback about the presentation and say, okay, I would prefer this, I like this. And this way, that's actually the boilerplate. It's a feedback app. It's very simple.
Okay, thanks.
Yeah, hi Vivian. Thanks for the insight, but I still cannot relate it to a practical terms how exactly Semaphore is applied. Theoretical, I get the concept, but if you can share, or if you can shed some light on it, on the practical aspect of it, be it with an example, that would be really great.
Mm-hmm. Yeah, so actually the boilerplate is an app that works and is actually real. And for example, want me to write the life or the code, or like more like the concept. I can go to the boilerplate and show how everything is connected.
In the
Yeah.
comment section, people ask like, can we dig deeper into one project like ZooPass and how we use semaphores? Is it also good for you, Almas? Like, is it something you want to ask?
Yeah, that will be better
Yeah,
if we can relate
maybe
to
we
any
can,
other. Yeah.
maybe we can
Yeah, so
see a project so that we can, relate with more semaphore.
mhm. Yeah, so going into a real world project will be like explaining the project will be more difficult because projects usually have more than Semaphore. That's why they usually integrate Semaphore for specific features, but they have more than that. So the easiest way to understand it is with a project that is only using Semaphore. In this case, like the boilerplate, we try to make it as simple as possible in a way that it can be seen as a real world application, but at the same time, it's just Semaphore and easy to understand. So I can go to the boilerplate and explain that and see if it's easier for you to understand how it can be used. And I'm gonna do that. I'm gonna read more questions. So this is the same. And with Supas, you prove that you have a ticket and that you can enter the event. It's mainly for that. How fast is the proof generation with Semaphore and where it is generated? So it's generated in the front end in the browser. So how fast? I'm gonna send also. Can you just mute that? Or
Yeah.
are you seeing the
Yes.
same presentation?
No. We see your.
Okay. And let's there is for the time, you can go to the documentation and the benchmarks are here. So you can take a look at the time comparing version 3 and version 4. So why version 4 is faster, improve generation and things like that because of the new tree we are using. And you can check benchmarks here, but you can also check benchmarks in here. So
I'm
you
not
can
hearing
run
the
benchmarks.
sound anymore. Is it me or?
I couldn't hear what you said, Magali. Can you repeat one more time, Magali? No, you cannot.
I think that they said that they can hear.
Okay, probably she also cannot hear me.
Mm,
Okay, let me just
yeah.
her.
Okay.
We also
And
oh sorry, so sorry.
oh yeah, go ahead.
We have one more question on the chat. Should I?
Yeah. Yeah, I'm gonna explain it. I'm gonna answer this and then go to the boilerplate. So here in this website, in this benchmark Semaphore PSD Dev website, you can run functions and you will see the time and also version 4, and you can generate it in your device. And then, yeah, you can actually generate it in phone. So that's why most of the projects that use Semaphore in real life use it with the fish, but also because Semaphore can be used in phones. That's why in Supas, we have it in phones, so you can use it, and because it's very light and optimized. So that's something that people like about Semaphore a lot. That's benchmarks, and let me go back to the questions. So that's related to proof generation and what is generated. Yeah, so this example is the boilerplate. So let me go there. Okay, so here is the boilerplate. You will have the contracts and the front end as explaining the architecture. And in the contracts, you will have, this is a feedback application. This is a feedback application where you generate your identity. And yeah, let me go through the app first. The boilerplate is a feedback application that in a way that everyone can join a group because the group is open in this case. Everyone can join a group and send an anonymous feedback. So we won't know who sent what. So then you create your identity, you have your private key, your public key, your commitment, and then these are the users. And then you join a group, and then after you join a group, you should be able to send a feedback, an anonymous feedback. Then this is interacting with the contracts. Yeah, so the group has 51 now, and then you will be able to, since you are part of the group, you will be able to send something. Yeah, you should be able to, and it should appear here. Yeah, so it's here. And that's the flow of this specific application. And how it's created, the application is interacting with contracts. So we have the contracts here. And we create the group here, the group that will contain everyone. And then we will be able to add members to the group, so that when you create your identity and you join a group, this join group is calling this function. So you are added to the group. And then when you send the feedback, what is happening is in the front end, I'm going to show that now, but in the front end, you will generate the proof, and then it will call this function, the send back function, send feedback function, and then you will be able to verify to validate the proof. This is the proof, and then organizing the proof here, and then you will be able to validate this proof. And using this group ID, because it's just one group. In this application, there is just one group, but you can have many groups, because in this case, it's just one open group. But in, let's say, if in this class we have different groups because we want to get feedback from organizers, but also from students, or we can create different groups depending on what we want. And actually, we are talking about feedback here. What do you think about something, or whatever you want to share? But it can also be voting. So you can vote on proposals in a group. You can add a proposal, and people can vote on that. So what is the interesting part here is that in a group, you can prove that you are part of the group. So it means that no one outside from the group can vote or can send a feedback. So that's the cool part. And this is a contract, so it's simple. So that's what is happening. And let's see what happens in the front end, which is what is happening in the browser. And here you will create your identity in the browser. So you create your identity this way. In this case, it's not deterministic identity, and then it will save your identity in the local storage in your computer, in your browser. You will have your identity there. If you go there, you will be able, and you go to identity displays, you will be able to see your identity, the private key. And there are different ways you can do that. This is an example for an application, but people should take care of the way they save the identities. And you create the identities, then you go to the group part. That's the first page you saw. The first page, the one related to the identity. Then you go to the group page, which is this one, and then here you will get your identity from the local storage, and you join the group this way. Well, this is to get the information. Let me go to the right part. So it's easier to find it. Mm. Mhm. Yeah, so you can call it here to join the group, and then let me find the right. Mm. Yeah, because you can use different things here you can use the free layer or the backend. So these are all the ways. So you shouldn't need all of this. You just pick one. You are gonna have whether a backend and you are gonna use this API, or you are gonna have this or any other free layer. For example, we have this Open Zeppelin one or the Gelato relayer that you can choose the one you want. And this way you join a group. This is the second page. And in this case with the API, in this case with the relayer, you call the function and this will generate a transaction and add the member to the group. And then, yeah, this is the UI. And when that's fine, when it was created using the API, it was added using the API or the relayer, then you will be able to see the third page, which is to generate the proof. And it's the same, you will use all these options. Let's go for the one that is faster, like the API, but you can also use the relayer, which is better. And it's actually backend too, but it's easier. And then you can just send the feedback. And what you're doing here is to call in an endpoint. I'm gonna go there now, but is to send the proof so that it will be verified in the contracts. It will let me go to this. This is actually the backend, how you can join the group. So what you're doing is interacting with the contract and just calling the join group function we saw in Solidity, generating a transaction. And then in the feedback app, you will have a transaction too, but this time is to validate the proof. And then calling the send feedback function we saw in the Solidity smart contract, the other function, then we will call this function with the parameters and the proof because the proof was already generated in the front end. So that's related to the API, how it's interacting with the contracts. Is it clearer now, like seeing this flow? Because this is the most common flow. In Supas, you will have the same because you need to create your identity, you need to be added to the group, and then you will use that to prove that you are able to enter the event because you are part of the event. So you already were added to someone that can enter the event. So it's the same. So in Word, it's the same. You have your identifier, and then you will be able to prove things because you are already there in the group. And pairwise, for example, is for voting. It's the same. There are groups, and then you join that you want to vote on specific round. And then since you are in the group, you will be able to generate the proof and send your vote. So it's like that. And yeah, examples. Another example. Yeah.
Sorry, before giving any other example, I think we have two questions because I
Okay, in the chat.
No. Yeah, Augusto raised hand and also Aria, you did, but you.
Yeah. Okay, I have a question. I think that I didn't understand what identity commitment is. So, do you mind to explain it in more detail, please?
Yeah. The identity commitment is actually like your public Ethereum address, your Ethereum address, Have you used that? Have you interact with, do you know like private key and public address in Ethereum, like a normal wallet?
We covered
That's
week one, yes.
okay, then great. So it's the same. So you can think of it the same way. The Semaphore private key is like your Ethereum private key, and then the Semaphore commitment is like your Ethereum address, which is public. So you can think of that the same way.
How can we generate that identity or address in Semaphore? Because I think that it's not safe to share your Ethereum address in a public chain
Yeah,
or something like
it's
that.
safe. It's safe. It's public, so you can share your public address. It's safe. So their commitment is public, so you can send it. And because the proof, when you generate the proof are not attached to commitments, so no one knows the commitment that sends specific proof. So that's fine. So it's public. No one can do anything with your commitment. They can only do something with your private values. What was the other question?
I think on the chat, yeah, if the information is stored on the browser site, how it's not compromised, social identity or data as per client server architecture, something like this.
Yeah. The identity. So the question is that if it's safe to save the identity in the browser, right? So if that's the question, it's not the best way. Or if you do it, try to hash it or do something. The best way, but that's apart from the Semaphore protocol. So in Semaphore protocol, we have the identities, the group, and the proof. But the way you manage your identities, that's apart, and you should do something about it. Every project will do something different. Some others will do something similar, but they have their own solution. But the best thing will be to have a wallet like we have for Ethereum addresses. So we have that to save everything and it's more secure. So that will be the best option, to have a wallet with the identities. So that would be better. But for now, projects usually save that in browser, or they also ask the users to download the private key so that it's not saved in the browser, and they can save it wherever they want and things like that. But there are different ways, but yeah, for sure, saving it in browser by default and just showing your private key in the browser is not the best way, but for the boilerplate, that's fine. Every application should take care of that. There is another. Can the inputs to be approved? Can the input? Yeah, the inputs can be anything that is a hash or of something. For example, if it's, you can save the videos or images in a server or somewhere and then hash it, and then use this hash for that, so that it's an identifier of your things. And then yeah, they can also be images or videos by using hashes. Any other question? If you have actually after the class more questions, it's fine. Feel free to tag me in Telegram, or yeah, let me know. I can answer everything
Maybe
in
we
the
can
chat too.
link to chat or maybe Telegram if anyone want to try and use. People ask how we can find beginner examples. So maybe we can share the,
The
like
in
GitHub link.
actually in the, yeah, we can share it in the chat. I'm gonna share all the links, actually the presentation too, in the chat.
Okay.
And here we can see all the projects. There are a lot of projects here. In the first page, you will be able to see these projects. But there is a list of projects using Semaphore. You can go through them and take a look at the code too. But actually, a lot of these projects and a lot of real world projects will integrate Semaphore, but will have a lot of other things in their architecture. So that's why it will be more complex to understand the big project, right? So you will probably need to go to the part that they are using Semaphore. So yeah, I'm going to share all these links in the chat.
I believe we don't have any other question. You
Uh,
have
here, maybe, I'm sorry. I have one more question. Do you think that we can use Semaphore for digital identity systems, or is not possible?
Yeah, you can. Yeah, you can, for sure. Yeah.
And how can we apply it? How can it, I don't know how to say this, but more like that. How can we apply it, Semaphore? Because in digital identity, we need, well, more exactly, in self-sovereign identity, we need the triangle of trust, the issuer, the node, the issuer, and the identity holder, and then lastly, the verifier. So Semaphore, how can, or where Semaphore can help in this system, or I don't
Mm,
know if you understand.
yeah, so people have used it, the identity part, to manage the identity, just the identity of the holders. And that's one way, just using the identity part of Semaphore for the holders. And then with this, you can actually also maybe have a group instead of people credentials, like have every credential can have an identifier, and then you will add this identifier, and then you will prove that you have a specific credential by proving that you have the private key of the identifier of that credential. That can be an example, but it can be used in different parts. It's not like Semaphore is for something specifically and it cannot be used in any other way. It can actually be adapted to something. And something that some protocols have done, actually Self protocol is using one of the circuits that Semaphore is using, the one for LinaMT, and it's actually using LinaMT. And some protocols, like identity protocols, what they will do is instead of using Semaphore directly, they will just use what Semaphore is using, the LinaMT we created for Semaphore, and they will use that because they don't need other parts. So that's also fine. You don't need to use the full protocol. If you don't need it, you can just also take some parts.
Okay, thank you very much. Right now, I think that I would like to build a human oracle with Semaphore. I maybe it's possible or not.
Yeah, I don't know, depending. I don't know, maybe. Our protocol is using Semaphore, so probably. But depending on what you are gonna build exactly, I will need to see details. But probably everything related to groups, yeah, you can use Semaphore probably. Everything that contains a group of something, a set, people, credential, whatever.
Do we have any other questions?
Yes, hello, can you hear me? Yep.
Yeah.
Just a small question. Why do you think that Semaphore is better than attributes-based encryption? Like even if I understand, of course, all the points, but do you have an opinion on that attribute-based encryption?
No, I don't know that. So I don't know. I
Yeah.
will need to take a look at that. to know
It just in short, it's also a way of encrypting data, and people who can decrypt are only the ones that are specified by attributes, and this is also a way of building groups. So it just made me think of this way of
I need to
encrypting.
look for that. So what is the name?
It's
Can you
attributes.
add it in the
Yeah,
chat?
I will share it in the chat. Okay.
Okay, yeah,
Thank you.
thanks. Yeah, thanks. Yeah, we are always looking to find the most optimized ways to do it. And actually, since we need to have it optimized for contracts, circuits, and also front end and back end, so it's difficult to find a way to have groups in all these environments and in an optimized way. So that may be the answer why we are not using something different, because we have experimented some things. And yeah, so I will take a look at these two. But we have tried different ideas, and since sometimes they are not optimized for circuits, sometimes they are not optimized for contracts, and that's why we don't choose something else. Because on-chain, most of the time, when you want to represent a group of something, you will use Merkle trees. So yeah, so I will take a look at that, but that's probably the answer, because we need to have performance on-chain, front end, and circuits. So having a good performance on all these things is difficult. So that's why sometimes we don't use other ways to create groups. But I will take a look at this specifically. Maybe this is more optimized in browser and backend and things like that. Because that's what happened before with other ideas.
Ariel, did you think about your question now?
Sorry, what?
Ariel was trying to formalize his thoughts
Okay.
and ask a question, and I just wanted to ask him, like, your mic is closed.
What about now? Oh, perfect. Hello, Vivian. Thank you for the session. I'm thinking in a kind of reputation system for students and learners like us. Like, hey, I want to prove that I was part of this specific cohort, but without telling you what cohorts I was part. Or maybe like, hey, I want to tell you that that I won some hackathons without revealing which hackathons or which technologies, for example. The use or the use case that I'm thinking right now is for recruitment processes where you want to avoid like hackers, for example, in North Korea or things like that. You want to prove that you have a track record that it's already verifiable. And the different projects and company and organizer could create these kind of groups. But I'm not like sure like if you can demonstrate that you are already part of different groups without revealing which groups.
Yeah, you can. And there I was opening these projects because Interrep was kind of like for like anti-civil, which is kind of related, but Unirep is exactly that. It's a project that was developed. It's a project developed by BSc too, and is not maintained anymore, but it was maintained for a long time, and it's exactly that. So you can take a look at this project.
Okay, thank you.
Yeah, it's exactly that reputation system, and it's actually using Semaphore.
We have one in chat.
Yeah, trying to build a system where people can be able to speak on sexual harassment. Okay, yeah, so yeah, that's actually possible. Yeah, with Semaphore by default, that's one of the main use cases. Mm-hmm. hackathons or give grants for using this technology. So we actually were we have been at a lot of hackathons and we did that, but not now. Now we are maintaining Semaphore and we are not adding new features. We are just maintaining it. And if a team wants to integrate it, we help them if necessary, and we give support, and we will add only things that are necessary for teams. For example, recently it was necessary for a team to be deployed on Gnosis chain, and then we will deploy it there. If you want it in specific network, if many people want it in specific networks, then we just deploy it on that networks and things like that. But we are not going to hackathons for Semaphore specifically right now. But we did that a lot for a few years. Yeah, open source contribution is welcome. Yeah, we are maintaining it. So yeah, is any open source contribution is welcome, and to improve something, to add something specifically. Yeah, for sure.
That sounds perfect. I believe we don't have any other questions. And thank you for today's session, Vivian. It was really amazing, and you answered all of our questions. Thank you very much. And if you have any questions, I believe, Vivian shared her contact, you can ask in the group chat too. And thank you very much, Vivian, again.
Thank you very much for the invitation. I'm going to share all the links, and feel free to ask any other question in the chat too, and tag me. I will answer as soon as possible, always. So
Thank you very much. Thank you.
Yeah.
Take care, everyone.